Um, Good morning, Sir Katara. I am Jefferson Istaro, and I will be answering the question in Chapter 6 and Chapter 7 by video presentation. So, let us proceed to the Chapter 6. On the Chapter 6, there are 4 questions. So, let us start. First question. Explain the objectives of development and quality plan. Objective of development plan and quality plan planning as a process has several objectives. Each is meant to prepare enough foundation for the following. First is scheduling development activities. The second one is recruiting team members and allocating development resources. The third one is resolving development risk. And the fourth one is implementing required SQA activities. And the fifth one or the last one is providing management with data needed for project control. So let us proceed to the second question. The second question is identify the elements of a development plan. So there are 11 elements of a development plan. So first is project products. Next one is project interfaces. Next is project methodology and development tools. The next one is software development standard and procedures. Next is the mapping of the development process, project milestone, the project staff organization, development facilities, development trees, control method, and the last one is the project cost estimation. So let us proceed to the third question. Identify the elements of quality plan. So there are 5 elements of the quality plan. Sa development plan is 11 and the quality plan is only 5. So what is these 5 elements of the quality plan? First is the quality goals. The second one is the plan review activities. The third one is plan review software test. The fourth one is plan acceptance test for externally developed software. And the last one or the fifth one is the configuration management. So let us proceed to the fourth question. Discuss the benefits of preparing development and quality for internal projects. There are 3 internal projects. The first one is the software development department. The second one is the customer, and the last one is the organization. So first is the software development department. First is avoiding budget overrun. The second one is avoiding damage to other projects due to the delays in releasing professional resources involved an internal project. The last one or the third one is the avoiding loss of market status caused by delayed completion of external project triggered by late completion of internal projects. And the next one is the customer. First is the smaller deviation from planned completion dates and smaller budget overrun. The second one is the better control of the development process, including earlier detection of potential delays. And the third one or the last one is the fewer internal delay damages. And the last one is the organization. First is reduce risk of market loss due to late arrival of the product. The second one is reduce risk of being sued for late supply of products. The third one is reduce risk of requesting a budget supplement. And the last one is reduce risk of impairing the firm reputation. So let us proceed to the chapter 7, and there are 3 questions. So let us start for the first question. First is describe the various software development models and discuss the difference between them. So there are 4. First is the software development life cycle, or in short SDLC model. The second one is the prototyping model. The third one is the spiral model, and the last one is the object oriented model. SDLC model. The classic SDLC model is a linear sequential model comprising several phases beginning with requirements definition and concluding with regular system operation and maintenance. At the end of each phase, outputs are reviewed and evaluated by the developer as well as in many cases by the customers. The outcome range from approval of the phase result and continuation to the next phase to demands to correct, redo, or alter parts of the respective phase. The waterfall model can be viewed as the basic framework from the other models, which can be considered as complementary and represent different perspectives of the process or as referring to diverse development contexts. Next is the prototyping model. According to the prototyping methodology, the developed system users are required to comment on version of the software prototypes prepared by developers. The developers thereafter correct the prototype and incorporate additional parts into the system. This process is repeated till the software system is completed or till the goal of prototyping is achieved. The main advantage of the prototyping over the SDLC model for small to medium-sized projects are the shorter development process, substantial savings in development resources, better fit to customer requirements, reduced risk of project failure, and clearer user comprehension of the new system. The next one is the spiral model. The spiral model provides an improved methodology for larger and more complex projects. This improvement is achieved by introducing and emphasizing elements of risk analysis and customer participation in the development process. Each of the model's iteration includes planning, risk analysis and resolution, engineering, and customer evaluation. The advanced spiral model, the win-win model, places extra emphasis on communication and negotiation between customer and developer. The customer wins by improving chances to receive a system that satisfies most of his needs, while the developer wins by improving chances of completing the project within budgetary and timetable constraints. The last one is the object-oriented model. The object-oriented model deals with a situation of intensive reuse of software components. According to this model, the development process begins with a sequence of object-oriented analysis and design activities. The design phase is followed by acquisition of a reusable software library together with regular development of the unavailable software components. Copies of newly developed software components are stocked in the library for future reuse. So the next question, the second question, explain the different aspects of verification, validation, and qualification for quality assurance activities. Quality assurance activities examine three different aspects of quality by means of software product, verification, validation, and qualification. Verification examines the consistency of current development activities with the product from previous phases. Doing so enables the examiner to confirm whether the developer has fulfilled his requirements while disregarding deviation from the original requirements that may have arisen during development. Validation represents the customer's interest by examining the extent to which the customer's original requirements have been fulfilled. The last one is the qualification, focuses on operational aspect where maintenance is the main issue. Qualification reviews project application of professional standards and coding procedures based on the assumption that applying these standards facilitates maintenance. Quality assurance activity planner are required to determine which of these aspects should be examined in each of the planned quality assurance activities. The last question, the third question, describe the model for SQA defects removal effectiveness and cost. There are two quantitative aspects of an SQA plan designed for a specific project. First is the total effectiveness of defect removal, and the last one, or the second one, is the total cost of defect removal. The model is based on the following assumption. The development process is linear and sequential, the waterfall model. A number of new defects are introduced in each development phase. The various review and test software assurance activities serve as filters, removing a percentage of the entering defects while allowing the rest to pass to the next software assurance activity. Incoming defects are the sum of defects passed from the former quality assurance activity together with new defects created in the current development phase. The next one is the cost of defect removal is calculated by multiplying the number of defects removed by the relative cost of removing a defect. And the last one is defect passed to the customer will be detected by him or her. Their full removal at this phase will incur heavy costs. So that's all. Thank you.